Hey everyone, welcome back to the P3 series. So in the last video, we started talking about the integration and we talked about how to handle when you have reciprocal linear function or quadratic of this form. Or actually, it would be better if we phrase it this way. Either way, we are using, for these two, we use tan inverse, and for this, we use the we also briefly talked about the integrals of sine, cos, and tan. And now we have to talk about the powers. So even powers are easy to deal with, especially the power 2, power 4 for sine and cos especially. For sine and cos, we have to use the double angle identities of cosine. Of cos of x. So let's see what we do over here. So for example, we know that cos 2x can have 2 cos squared x minus 1, or it could have 1 minus 2 sine squared x. Now, when you rearrange these to make cos squared x the subject or sine squared x the subject, it's a very familiar, easy to remember rearrangement. So it becomes 1 over 2, 1 plus cos 2x, or theta, whichever way you want to do it, and 1 over 2, 1 minus cos 2x. Now let's see how to handle, how to integrate these also. So for example, you are asked to integrate cos squared x dx. So to integrate this, we have to integrate this expanded form, 1 plus cos 2x dx. So 1 over 2 is just a constant. It can come out, so it has nothing to do with this. So the integral of 1 is x, and integral of cos 2x, as we saw in the previous video, it's sine 2x, same angle, but divided by the derivative of 2x, which would be also 2. Now we just simply multiply the 1 over 2 inside, 1 over 2 x plus 1 over 4 sine 2x plus c. Very straightforward. The process for sine squared will also be very straightforward. However, let's up the difficulty and do raised to power 4 for sine. Again, the cos raised to power 4 would also be very similar. So sine raised to power 4 x dx. Now, to expand this, we need to first expand sine raised to power 4 separately. So we know that sine raised to power 4x can be written as the square of sine squared x. And sine squared x, we wrote it as 1 over 2, 1 minus cos 2x. So basically, like 1 over 2, 1 minus cos 2x whole square. So when we make the square, this becomes 1 over 4, 1 minus 2 cos 2x plus cos 4, sorry, no, cos squared 2x. So when we multiply 1 over 4 inside, we get 1 over 4 minus 2 divided by 4 is 1 over 2 cos 2x plus 1 over 4 cos squared 2x. Now, we have a problem with this. We don't want to see this. So what we do is we expand cos squared 2x with its own double angle identity. So if it's cos x, it becomes double. So if it's cos 2x, the angle inside would become cos raised to power 4. Sorry, cos 4x. Sorry, my bad. So cos squared 2x will expand into 1 over 2, 1 plus cos 4x. So when we plug it back into the sine raised to power 4 form, this becomes 1 over 4 minus 1 over 2 cos 2x plus 1 over 4, 1 over 2, 1 plus cos 4x. When you multiply the 1 over 4 inside, you get 1 over 2 cos 2x plus 1 over 4, 1 over 2 becomes 1 over 8 times by 1, 1 over 8. And 1 over 8 times by this is just 1 over 8 cos 4x. This is not fully simplified either. So we have to add the 1 over 4 and 1 over 8. So 1 over 4 plus 1 over 8 to make it into common denominator times by 2 times by 2. So this becomes 2 plus 1, 3 over 8. So 3 over 8 minus 1 over 2 cos 2x plus 1 over 8 cos 4x. Now, back to integration. To integrate this would be equivalent to integrating 3 by 8 minus 1 over 2 cos 2x plus 1 over 8 cos 4x dx. So the integral of 3 by 8 would be just 3 by 8x minus 1 over 2. Integral of cosine is sine with the same angle, but divided by the derivative of 2x plus 1 over 8 sine 4x divided by 4 plus c. Now we simplify this. 3 by 8x minus 1 over 4 sine 2x plus 1 over 32 sine 4x plus c. So easy. The process for cos raised to power 4 would be also very similar, only with slight few changes over here. Now let's see how to deal with tan squared. For tan squared, you have to remember the identity that connects it with secant squared. So tan squared is basically secant squared minus 1. So if you want to integrate tan squared x dx, we are actually just simply integrating secant squared x minus 1 dx. So that would be just simply integral of secant squared is just tan x and minus x plus c. Very straightforward. Now, for the odd powers for odd powers like power 3 commonly, we can use integration by substitution also. And we will see that briefly in the integration by substitution video. However, the questions that you will see in the exam don't always use the integration by substitution. They are phrased in a very different form. So for example, this is example 4. Okay, this is example 3. Okay, example 4. The question could be phrased like, show that sine 3x is identical to 3 sine x minus 4 sine cubed x. And the second part would be hence find integral of sine cubed x dx. It's possible that they could use some limits also, but let's do the indefinite form. Okay, so for the first part, we need to see that we can expand sine 3x as sine 2x plus x. So using the angle addition formulae, this becomes sine 2x times by cos of x plus cos of 2x times by sine of x. So sine 2x is basically just 2 sine x cos x times by cos x plus, since we want to convert it into sine form over here, so we will use 1 minus 2 sine squared x times by sine x. So cosine becomes cos squared 2 sine x times by cos squared x plus this becomes sine x minus 2 sine cubed x. Now cos squared can be written as 1 minus sine squared. So 2 sine x, 1 minus sine squared x plus sine x minus 2 sine cubed x. So that would simplify to 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. And now finally, this would become 2 plus 1, 3 sine x minus 4 sine cubed x. So this is this. To find the integral, we know that if sine 3x is identical to 3 sine x minus 4 sine cubed x, this would mean that the 4 sine cubed x can be written as 3 sine x minus sine 3x, and we can divide by 4 also. Sine cubed x would be 3 by 4 of sine x minus 1 by 4 of sine 3x. So to integrate sine cubed x dx would be equivalent to integrating this side dx. So integral of sine is minus cos, so this becomes minus 3 by 4 cos of x. And again, you have minus, so minus minus will become plus 1 over 4 cos. Actually, let's keep the sign first. Minus cos 3x divided by 3 plus c. Now we simplify. Minus 3 over 4 cos x minus plus 1 over 12 cos of 3x plus c. So you could expand it this way also. Or you could integrate it this way also. So the process for cosine cube will also be very familiar, and then I think there was a past paper question, I think in 2019 or 2020 somewhere also, which was very familiar. I think it was with the cos 3x instead. All right, so hopefully we'll see each other again in the next video when we will discover integration by substitution and integration by parts. All right, so take care. Bye-bye.